So this is basically where we're going to get to at the end of section 2. And for week 3, we're going to build out all these UI elements and connect them up, to the relevant methods and properties that are in our logic of our click detector script. Or this one here, click position manager. It's on this click detector game object. So last week we kind of talked about in game objects. We talked about the canvas, the event system. We talked about the image, the text, and the slider. And to wrap this up for this week, we're going to move into the toggle, the button, and the drop down. And then this gives us everything we need to expose out to the user so that they can change properties on our code and change the function or the functionality that we've built so they can express themselves however they care to with our program. So we're going to be spending most of our time within the UI hierarchy within the canvas. So we're going to be building out all these different components and then connecting them up to our main script. So this part, actually, I get to toward the end of the class. Let me just take that part out. Just give it a second. It shouldn't take that one. There we go. All right, so let's start from the top to the bottom and just recreate it. So we have a text element here that is just giving basic instructions to the user, just giving some details of the information about the app, and then it's giving some instructions how to use the app. And then this will be a toggle that allows us to say whether the content should be destroyed after 3 seconds or it should stay forever. This is going to be a drop down that lets us choose the type of content that we wish to draw, sphere, cube, or cylinder. There's a clear button that just deletes everything that's on screen. This is a slider that's going to control the size of the content that we're creating. And this controls how much red to we allow full expression of red, and as you clamp it down, there's less amount of red going to be mixed into our random color palette, and same with green and blue. And then this text element here, got some errors. Let me see what's happening. My fault. This is where I was at the end of last class. Delete that. And that was actually dealing with this mouse position down here, showing where the mouse is. All right, perfect. So if I click play, you can see that where I move left, right, up, and down, we're showing the mouse position on the screen. And I can paint, I can clear stuff out, I can paint small stuff or big stuff, and pull out or pull back in red or any mixture of colors, really. And if I turned off time destroy, stuff just stays there, and if I turn it back on, that stuff gets deleted and can delete. Perfect. So first off the bat, let's click somewhere in our canvas and then go to UI text. And I gotta name it something, so we'll call it project info so that we know what we're building with it. I'm just gonna rebuild all these parts of UI, but on the right hand side. So I'm just gonna go ahead and clamp everything to the bottom right, because all this stuff is clamped to the bottom left. And so I'm just gonna move my text over a little bit, and I'm gonna recreate what I see over here. All right. name the project and give some directions. So right off the bat, you see it like the text is too big. So I could just start shrinking it down and maybe something like a 14 font or something. That should work well. I see that I should change the color to black. And also, since we're on the right-hand side, we can align it to the right. I just center it up horizontally. And now that it's all rebuilt, I can just position it up at the top. And now I can, yeah, this looks good. So this up here, oh yeah, so this was the only part of this left side UI that's clamped to the top. And let me just clamp it to the bottom along with the rest, just so it kind of moves with everything. Cool. So it's looking pretty good. Position. So we have our text label done. So what's next? We have a toggle. So I'm going to create the toggle. I'm going to pin it, anchor it to the bottom left, or bottom right, reposition it. Now the toggle has a few different game objects in it. It's a nested hierarchy. It has children game objects I have to go into. And what I'm interested in right now is going to the label. So here's the text element that gives the label of this thing. I'm going to call it timed destroy. And once I did that, I should readjust not the width, sorry, the position X, and position it nicely so it's on screen. And notice how I'm just moving or repositioning the top game object, and everything else comes along for the ride. So that's the beauty of that hierarchy, that parenting, is that they're inheriting the transform with their parent. You only have to move it once. So if I go into the toggle component, one thing to note is, toggles can be on or off. So what they're simulating or replicating is basically a Boolean. So you have true or false. And then it's like, well, what do you want it to default it to? True or false when we start off. So for this, I got to go into my code. And this is basically what we're changing. So if you remember last week, this just had destroy. And what are we destroying? Well, this is the reference to the game object. Here it's just called primitive, and then we're destroying after 3 seconds. But if you notice, this is wrapped up now in an if statement. And what's the if statement saying or checking? It's checking this time destroy is on. So if I come up here, it's a property. It's a private bool called time destroy is on, and I'm setting it to true. Just so you know that if you create a bool and don't assign it to anything, it goes to the default, and the default value is true, but I'm just specifically specifying it that's true. So what it's saying is, okay, I've got this property up there called time destroys on, and then every time we create something, we check, well, is that true or false? Well, by default, it's true, which is what the behavior we're used to, but that doesn't necessarily have to be the case. You can allow the user to decide what they want. But we do need to understand what the default value, default property would be, and it is true. So that's great. So we leave that on. And next is, okay, on value change. So here's the event system, right? So when we just provide this user interface, we allow the user to change different parts of our code, but we don't know when, or if or when they're going to do it. So to handle this like unknowingness, this like we don't know when it's going to happen, we can use what's called events. We can generate events. We could fire events, and then we can listen to those events. So whoever is in charge of the event can fire it, can know when to fire. Like the toggle knows when the user has clicked on it. So the toggle will be responsible for firing off the event, that the user has clicked on this toggle. And so this is like the event that gets fired off, and it will pass a bool. This is the event data. So for a toggle, it makes sense to send a Boolean. What did the user just change it to, true or false? And so part of this event system is like, well, yes, so here's the event system. It was created when we created the UI. But and this toggle will be creating an event and firing it. But who should be listening to it? Who should be subscribing to it? And so now you have this idea of, well, there's these event listeners. And an event listener is really just like a public method on another object. So it's like, well, who's this event gonna fire? Is gonna which methods will it call when the event is fired? And that means you have to like assign public methods to it, because these are methods on other objects, so they have to be public to be able to call them. So we can add, you can have many, you can call many methods. You can have many subscribers, but in this case, we're just having one. And so we're going to add one, and it's going to be a public method on this manager script, this click position manager script that we have. So that's why we have a bunch of public methods now down here. And I'm interested in this one. So you're going to say, all right, I'm going to create a public method. It returns nothing, so it's void. Here's the name of it. And it's going to receive as input, it's going to receive this bool, this temporary variable. And this is going to be called every time the user clicks that toggle, and this bool will come in, and then we set our time destroys on, this property to it. So it's up here, time destroys on, defaults to true, but the user can at any moment click that toggle, and whatever they've clicked it to, we can set this property to from the method. And that property end up is being used down here in our internal logic when we do decide that the user is clicking on the screen and that we want to paint something, and we just created this object, and we set its color and its position and stuff, and then we say, all right, what does the user want to do? What was the last state that they left the toggle in, and do we want to destroy this thing or not? So those are all the connecting points that we need to handle the UI event. So once you say, okay, we're gonna like assign a listener here and say, who is it? Well, it's going to be sitting on this click detector game object, and within this click detector game object are other components, many components or whatever components, but the one that we're interested in making an event subscriber, the public method we want to call, is sitting on our script, the click position manager script, which is a component object. And we see that there's like a lot of the static parameters. These are just like exposing everything out that it can. Don't use the static ones. It's like a cheap version. It's like not, we want a dynamic call. We want whatever the user changed the variable to at that moment, we want to call a public method that actually receives that type of input. And that's why the dynamic bools are up here. Now, some of this stuff has already been exposed from Unity. Like, this is not the stuff I created, so I don't want to call it. But here, this is actually my method name, toggle time destroy. This is the public method I created on my on this click position manager script, and so that's the public method that I want to call. So it's all set up. So everything should be set up, and so when I click this on and off, it'll specify whether we should use time destroy or not. So if I paint once while this is on, it gets deleted. I turn this off, I paint again, doesn't get deleted. So this stuff got generated, but it didn't call that destroy function, that destroy method. And if I turn it back on and I paint, and this gets deleted, and I can turn it back off and paint, and it's forever. I can turn it back on and paint. And so now I can show you that this toggle is working as I turn it on and off and paint afterwards. It is setting that property through this method call, and it's updating this property up here to true or false, which is then designating, then when we paint an object, we figure out if we should destroy it or not. All right, so the next accompanying one would be the clear button, because what if if the user had painted stuff with time destroy off, but their screen is getting cluttered and they actually do want to delete it. So let's look at a button. All right, so a button got created. Let's call it something right away. I'll call it destroy all. Sorry, I didn't put, I should probably name this toggle too. I have other like objects up here that are named similar, so I'm just trying to like name them something similar, but remember that it's like my second version of the UI over here. So anyway, this is going to be a clear button. And I open up the button, and notice we have a few different objects too. We have the text underneath here, so I want to change that to clear. It looks like I can shrink the text down. It's a little big. And with the smaller text, it looks like we don't need as big of a background on the button. The image part of the button is too big for the amount of accompanying text, so I can shrink that down. And I can position it. All right, so if I come down here, we have the image component. This is like the visual, this little background image. And then we have the button component, and this is responsible for the interactivity. So it's a simpler UI element. It's just you don't have to do any settings because there's nothing really to change for how a button would default behavior. And notice it's callback, it's event system, it's event data. It's just going to call a method. It's with nothing. There's a button click just happens. It's like a toggle is sending data, was either true or false, and a slider is sending data, it's sending the float value at that moment. But a button click is just a button click. It's just gonna, when the event is generated, is fired, it just needs to call a method. And this one is interesting because if I come down here, we're actually going to call this method. So this is a public method, so we can call it from the button's event firing. And we're going to call it destroy objects because that's what it makes sense doing. And we're going to loop through. I'm going to have to explain this code, but here's a for each loop. It's a simplified version of a for loop. And basically, for everything it finds, every iterable object that it finds in a collection, it's going to run code on that object. So to explain what's happening here, first I got to come up a bit and explain this line of code. So if you noticed last week when I was creating stuff, when I was creating painted objects, they were just kind of flooding the root of my scene. They were appearing all the way down here. But notice when I paint, they're not doing that. They're not showing up here. But if you notice, there was an arrow here on click detector, and if I open it up, all the painted objects are now going underneath the click detector game object. And so this is really great for organizational purposes. So it's like if I close it, you don't have to look at it. You don't see all this flooding of new objects. But it's also useful to know where. Like now I know where all of my painted objects will appear. And if they are currently in the scene, they're going to be underneath this click detector. So if I turned off time destroy, now we have stuff underneath there, but I can't delete it by time. I can't just leave it alone and let it delete. And if you notice, if I click the clear button, that is already set up. It does clear what's underneath there. So let me explain what's happening is that whenever we create something, we create a game object, we have a reference to it. And then we use the dot operator and get its transform property, which is like shorthand way of saying get component method call on a transform type. But in any case, we get the transform component of what we just created. So if I turn this sphere back on, it's saying get me this transform. And this is where the parenting happens. So you notice that you can go to the parent property of what we just created, and you can assign it to something. We can assign a parent to what we just created. And in this case, it's like saying this dot transform. It's saying whatever the object instance of this script is, go get its transform component. So we did use the this operator previously. And what it's saying is there could be many objects created from this class, this click position manager script. So if I click on it, it's this script, this CS file that's sitting on our hard disk, and it's just a class. But there's objects, instances of them created. There's many of them. We don't know which object is calling this code. So it's saying whichever object is calling this code, whichever instance, go get your transform. So this instance of click position manager, this component object, is connected to this game object, this click detector game object. And so that's this transform component that we're referencing in this dot transform. And so that's why it's saying, okay, whatever we're creating, all these painted objects, go place them underneath this transform. This transform will become the parent. So parenting in Unity is not done with the game object, it's done with the transforms. So it's easier because parenting really impacts, you inherit your parents transform. That's why it's so super useful for organizing, and it's super useful for like aligning, and your UI stuff moves along together, and it's super useful for inheriting transforms with 3D objects. They inherit the transform of the parent, so stuff moves along with its parent. But in any case, you see that now. That's why, because of that line of code, everything I'm creating is getting placed underneath the click detector, because the click detector's transform is becoming the parent of what we're creating. And this is super useful because here it allows me to do this. So when the button is clicked, the clear button is clicked, and this destroy objects method is called, what we do is we loop through for each child in this, we destroy that. So what this means is we declare a variable of type transform, call it child, and in is a special keyword. For each is a special keyword too. There's a for each loop. But this is like saying for each type of type transform that's underneath this transform. So this is like shorthand of saying this. Whenever you just say transform, you're mentioning whatever transform that this object is relating to. So whatever collection of transforms are held within this transform, we will loop through each one. So this reference of child moves through the list, the collection of transforms. So there could be none, there could be many, and there could just be a few. So it depends. When I run the game, the collection of transforms underneath here are 0. So we would loop through 0 times. And when there's just many, we're going to loop through each one by one, or if there's just a few, we loop through each one. But that's the beauty of this, is at a moment's notice, we look within this transform and they tell me how many child transforms there are. And for each one, this reference will loop through them and run this code. So we destroy that child, but not just the transform component. We go up to its game object. So as I unclick this and I just paint, it's going to loop through each one of these, and the child reference is going to move through these one by one by one. And what happens is the child reference is pointing at the transform, but it's saying, hey, go up, let me know about your game object, because I want to delete the whole thing. I don't want to just delete this transform component. I want to delete this entire game object, and then move on to the next transform and go up to your game object and delete the whole thing for as many child transforms that exist. So that's a great line of code, and that's a for each loop. And notice that the for each loop has an input, the smooth parentheses, and it has some logic that's run in a block of code, and it's run for each iterator, each element that is in this collection, these child transforms that exist in this transform, which might be 0. So to wrap up this clear button, we built the whole thing, I explained everything, we wrote the code for it. We just have to say, hey, when the user clicks on this, And this event is fired. Who wishes to listen to it? Which public method of an object should we call? So we drag on the click detector. We go to our script, our component object that we've written. And there's a lot of things, there's many things that we can call because it's just like opening up the whole thing. And there's stuff that we wrote and there's stuff that Uni wrote. And it's just a generic method call. So it's like listing everything. But we have to find this. Destroy objects. That's the method I wrote that links to this type of functionality. So if I paint and clear, and it clears everything out. Cool. I'm going to stop this video.